All right, we are in week 3. We're talking about investigating roots. Today in class, we built big old cubes, just like this, only out of magnet squares. And just to review, we saw that if you have an edge length of 1, you get a volume of 1. And that's because 1 cube is 1. If you have an edge length of 2, you get a volume of 8. Because 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. And so I thought it was a good idea to actually build and see that math in real life. Right now in this Edpuzzle video, you're going to need to have all these terms in your notes. Square root of a positive number. We have perfect squares. We have the radical symbol, and of course, on the next page, we'll see the cube root, right? And so, right now, for the Edpuzzle note sheets for you. Let's turn the page. And we can see the cube roots, and where is that? There it is. There's the symbol right there. Okay, so we're going to talk about cube roots in this video right here. You don't have to write down everything, but I'm going to write down what I would like to write down. So it says find the cube root of 8 over 27. And before we do that, we'll find the cube root of 64. So we're going to find 2 cube roots right now. In your notes, write down this right here. That is 4. If you had that cube that could fit 64 unit cubes, it was really big, right? And you look at the edge was a length of 4. 4 across, 4 up, 4 back. Okay, so that is because 4 cubed is 64 cube root. So now let's find the cube root of this fraction. To do that, we're going to find the cube root of the numerator and the cube root of the denominator. We also did these cubes too. We found that the cube that had a volume of 8 had a side length of 2. You look back at the table or rewind the video. And what about the cube with the volume of 27? Had a volume of 3. It had an edge length of 3. Okay, so that is like the conceptual understanding of cubes and square roots. And it's really important because we want you to not only be able to get the right answers, but really understand it. So now, let's talk about square roots. And if you're using a calculator, stop, because, this is good practice. So the square root of 16 is 4. Why? Because 4 times 4 is 16. So right now, what I want everybody to do is make a perfect square list and a perfect cube list. And have them in your notes and bring them to class every day. So we're just gonna write up to let's go up to 15. Oh my goodness. We're just gonna do the cubes up to 10. Just because the numbers get so large so fast. Okay, so all we're going to do is we're going to cube these numbers. So the first perfect square is 1 and 4. 3 times 3 is 9. Squared, you can just put a little square. 4 squared is 16. 5 squared is 25. 6 squared, 36. 7 squared, 49. 8 squared, 64. 9 squared, 81. 10 squared is 100. 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. I thought I was going to 15, and 15 squared is 225. If you memorize this list, you're going to make the next couple weeks of your mathematical life a lot easier. So go ahead and do that if you want your life to be easy. Okay, now let's do the cubes. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 3 cubed is 64. 5 cubed is 125. 6 cubed, I think, is 216. 7 cubed is 343. 8 cubed, we've reached the limit of Field's memory. So let's see what 8 cubed is. 8 times 8. Oh, wait. 8, 512. All right, 512. Got it now. This is 729. Let's see. 9 times 9 times 9. 729. I had it. I believe in myself. And not 100, but 10 cubed is 1000. Okay, so make sure you have both those lists in your notes. They're leaving the screen right now. Okay. On to cubes. So now, see, look, because you just put 343 in your notes, so you know that's 7. Right? So just look at the list. 10, 9, so that is going to be a very fast assignment for you once you have your list. And as is this one. Look, I told you it's going to make everything very easy. So 216, so let's talk about this. We have a brand new inverse operation, okay? Before, you might have had something like this. Notice this 3 and this 3 are different, and they shouldn't be treated the same. So this 3 is where you would divide both sides by 3, and you get whatever this is. But that's not what we're doing here, okay? Oh, here we have an exponent of 3. We are not going to divide by 3. We are going to take the cube root of 3. That will cancel the 3's out. And we know that the cube root of 216 is 6. And so this one, so the answer is 6. But I don't see that. I see the cube root of 6. But that's not right. That's a different number, and it's definitely not 7. That would be 343. So I'm going to say the answer is none of the above. None of the above. And you can see the work right there. That was tricky. Try to trick me. Okay, I'm going to do one more for you. 64. I didn't look at the answer. 64. Okay, so the cube root of 64, right? Because n cubed equals 64. So we're going to take the cube root of both sides. Please make sure you say it like that. I canceled out the exponents. And the cube root of 64, look at your cube list, it's 4. And the square root of 64 is 8, but the cube root of 64 is 4. And what about negative 4? Well, let's see. Would 3 negative 4s be 64? No, because 3 negatives would be a negative. So in the book, we talked about positives and negatives can both be the square roots, but that's not the same for the cube roots because 3 negatives is a negative. 2 negatives is a positive. Okay, let's talk about the decimals and fractions. So we can see, if you look at your cube root list, what does this one look like? This one looks like 12, right? But so where does the decimal point go? Does it go here? Does it go here, here? Let's think about when we multiply decimals. We don't even need a calculator. We're just going to think. So if I when you multiply decimals, just a random decimal, 7.23 times 0.1. in order to multiply decimals, you count the number of digits behind the decimal. And then in your answer, that's where you put the decimal. So that there's 3 digits behind the decimal because there were 3 digits behind the decimal. So here we have 2 digits behind the decimal. So thinking backwards, our numbers must each have only 1 digit behind the decimal if we need to get a total of 2 digits behind the decimal in our answer. So 1.2 times 1.2 is going to be 1.44. Now in my factors, I had 1 digit behind the decimal, but there's 2 factors, so total of 2 digits behind the decimal, which is why that's what we see in the answer. Okay, let's do one more. Oh, let's do a fraction. You want to do one more like that in class, but this one is not bad. Okay, so we're just going to take the square root of the numerator and the square root of the denominator, and you have your list. You should see 7 and 9 are the square roots of 49 and 81. And we're looking at square roots. 7 ninths. All right, any questions? I wouldn't know unless you put them as a traffic light problem. So I will post a traffic light Google form with this video. Let's do, so sad part is I assigned these on Friday, but only one person has done 2 questions so far from this one. So that's all I have to put in the video. So make sure that you are, doing the problems when they're assigned, not when they're due. Then I'll have better data for your video. Find the solutions of the following equation. X cubed equals negative 512. And 512, what was 5? Was that 8? 512? Let me go through it again. I erased my list. Yes, 8. Okay, so the cube root of 512 is 8. That's what I was trying to remember. And here we have to take the cube root of 512 because we see x cubed. So that's what I'll do. And I'll get x equals negative 8. Well, that wasn't so bad. It wasn't a challenge to me. But if it is to you, then you can post it to the traffic light problem and make it red. Okay, the cube with a side of 343. So we're going to take the cube root. And we have our cube root list. So you should see that 7 is as a cube, the 343 is a cube root of 7. Done. All right. Not too bad. I hope that's helpful, and I hope to see everybody completing all their assignments on Khan Academy and getting 100%. I will see you in class.